We've been discussing ionic compounds and how they're soluble in water, and looking at how they dissociate. Ionic compounds dissociate when you put them on water, and that's what makes them soluble. Right now, we're going to talk about a special type of reaction called precipitation reaction. And your textbook actually has this set of pictures, and it's actually a really good set. And I want to just walk you through what's going on in here. So in this beaker right here, we have a aqueous solution of lead nitrate. Okay, so lead nitrate is PbNO2. So let's see here. PB, oh, P, capital P, PbNO3, 2. So this, when put into water, breaks apart into these ions. And over here we have potassium iodide. So Ki, put into water, breaks apart into these ions. Interesting thing happens. When you mix these two solutions, all of a sudden you get this weird yellow stuff. Now what's happening is that these lead ions and the iodine ions are combined and form something that we call a precipitate, this lead stuff, this yellow stuff. And so we see that some ionic compounds are actually not soluble in solution, and so lead iodide is one of those examples. Now potassium iodide is still soluble in solution, and actually this should say, this is a typo in your textbook, should actually say potassium nitrate, so a KNO3 aqueous. But this is actually soluble in solution. This is insoluble in solution, so it precipitates out as this yellow stuff. Now, this type of reaction is, oddly enough, called a precipitation reaction. And precipitation reaction occurs when you mix two water-soluble compounds and it produces an insoluble product. We call the insoluble product the precipitant, okay, or the precipitate. Now, in this case, we have our complete chemical reaction here. Lead nitrate plus 2 potassium iodide goes to form lead 2 iodide and 2 potassium nitrates. So the 2 potassium nitrates shown over here. And so if we consider this solid right here is our product. That is the only product there. Now, this type of reaction is also, so it's called a precipitation reaction. It's also called a metathesis or double replacement reaction. So it involves swapping of ions. See, what's happening is this cation is bonding with this anion, and this anion is bonding with this cation, and it has the general form of this. A plus AX plus BY goes to AY and BX. And so you need to be able to recognize exchange reactions, and so all exchange reactions have this form right here, and a special type called precipitation reactions will form an insoluble product in an aqueous solution. But how can we predict what will actually form an insoluble product? Well, there's a table in your textbook that has solubility guidelines, table 4.1, and this you'll want to spend some time, spend some time memorizing. And notice the general trend here. It's got anions over here, cations over here, okay? And it says that compounds with anions, these particular anions are soluble compounds. And there are some exceptions to some of these. So anything with nitrate as its anion, anything with nitrate has no exceptions, so all nitrate compounds are soluble. Anything with acetate bonded to it. So in an ionic compound, they're all soluble. But chlorine in general is soluble, creates soluble compounds, but it has these 3 exceptions: silver, mercury, and lead. So chlorine bonded to any of these 3 metals would be insoluble and would show up as a precipitant. Again, we got bromine, iodine, and sulfur, generally soluble, but has a few important exceptions. So take time learning these exceptions here. And then down here are anions that make things generally insoluble. Most hydroxide compounds are insoluble except for things with ammonia, alkali metals, or calcium, strontium, and barium. Notice that these calcium, strontium, and barium, when you have calcium hydroxide, strontium hydroxide, and barium hydroxide, those are important compounds. What are they? Think about it. Those are bases, right? And in particular, those are strong bases, as are any alkali metal bonded to hydroxide. Phosphates are generally insoluble. That means they'll make a solid substance, but they have these important exceptions: ammonia and alkali metal cations. And so that's how you read the table and use this table to predict what will be soluble and what will be insoluble.